Oh, are you having fun yet? I know I'm having fun, and I'm really interested. Well, I guess I can see it from the others. Are you keep the feedback coming? Are you jumping through this? Are you watching the Edpuzzle version? Well, I get to see that. Are you watching the YouTube version and just jumping to the bits that you want? Is it like really flying too quickly, or is that working quite well because you can pause? Not quite sure, so keep the feedback coming and I'll keep adapting as it does. So, question 5. Okay. I've got my touch portal set up here. It's beautiful. I've got a screen here with, anyway, you're really interested in that, hey? So I can be like, well, there we go, look at that question, or there we go, look. Yeah. So here we go. We've got question 5 and it's asking us about graphs or functions on Cartesian plane. Consider this. So we've got g of x is sketched below. So here's g of x. That looks like it goes through 0, 5. It's got a turning point there. It's got another x-intercept. So it's got a few things that stick out about it. That's what g of x is. And we need to draw accurate graphs of h of x and then p of x. So what are we asked here? So the main question is here is that I'm going to ask you, what does the -5 do to our function? What type of transformation does it do? Okay, the transformation that it does is it translates the graph down by 5. So all we need to do is we need to take this graph and we just need to move it down by 5. We've got that turning point. So when it says accurate, we need to move everything down. Now the key points here, we've got this, we can move down. We've got a y-intercept, we can move down. We've got an x-intercept, we can move down. We can move those down. And that's what it means by accurate, is that it's not, oh, it moved down by a bit. No, because these should go through those particular points. But it's really just, the test is, what is the -5? What transformation does it do? Okay, then next question, same idea. We've got our original function, g of x, I think it was. And now what we're doing is we're subtracting 5, but we're doing it there. Interesting. So what does that -5 inside the bracket do? And as a hint, before I actually put that, there's the question for those that are Edpuzzling it up. Consider a function like if you had x minus p squared plus q. Like that would maybe be in turning point form for a parabola. Think about this minus p. If you had an x minus 5 over there, what would that do? What transformation occurs? The transformation in this case is, well, it's a -5. Remember, it always feels like it almost does like the opposite. So in this case, it's going to move it right by 5. Right by 5, right? So everything's going to move right by 5. Now remember, you've got your key points, that turning point. You know that these intercepts are going to move right by 5. Maybe you could see, well, you haven't gone by 5, so maybe you won't see the y-intercept when you draw your new version of the function. But that's how you can get it accurate, because you know that your turning point must go there. Okay, last question, a little bit trickier. For what values of k, well, g of x equals k, have roots that are a different sign? So you think, what's this question? It's asking nature of roots. So have a look at your original function, g of x. Here it is, nice. It's got roots of different sign, right? Here's one root. The one root is -1 because that's an x-intercept. And the other root is 5, 0. And we've got a turning point up here at 2, 9 by the looks of it. And we've got this value here is at 0, 4. So our two roots are of different sign. So g of x equals k. So when there are two ways of looking at this distinctly, what do you think so far? What do you think like of a method to solve this? Well, I want to go through 2 different ways. The one way is to look at it in terms of those transformations we've just looked at. Think of this as g of x minus k equals 0, because that's what we'd do when we find roots. We'd find equals 0. So what can we subtract so that you have roots that are different signs? So if you subtracted, I'm going to tell you maybe one thing that wouldn't work. Can you imagine you subtracted a full 9? Then if we subtracted 9, then wouldn't our turning point be there, and the graph would look like that? We'd have 1 root. So clearly we can't subtract 9, so k can't be 9. Or if we subtracted 10, 11, 12, 13, it would be down here, then we wouldn't have any roots. So this is the type of thing the question's asking when you see other questions like it. That's why I'm spending not just, 2 marks, it's testing something there. I'm saying 2 marks, it's not 10 marks to really ponder over for 10 minutes. But it's worthwhile because this question is all about nature of roots, and it comes up in so many different ways of how we can ask nature of roots. They're equal roots, 1 root. Here, no roots, no real roots I should say, because it doesn't cross the x-axis. Here, if we took it up by 1, well, there we go, there'd be 2 roots, and so it would go. So we need to ask ourselves, what can we subtract from this such that we still have roots of different signs? So let's just play with some options. Less about finding. Definitely don't want to give you the exact answer for this one. Let's say we moved it down by 1. Would we still have roots that are different signs? In other words, 1 negative, 1 positive root. Well, if this went down by 1, then it's going to go through there. So this root on this negative root must still have a negative root. There's going to be a turning point over there. That's going to have gone down by 1. And this bit here is also going to move down by 1. So yeah, it would look like the graph's still going to have 2 roots of different signs. There'll be 1 negative because it has to cross that axis, and this other root's definitely going to be positive because it has to cross. If we moved it down by 2, well, if the y-intercept is positive and it's got this shape, it must have a negative root and it must have a positive root. So that's the idea. I think it's worthwhile just quickly exploring this in one other way. We didn't do it this way in class this year. G of x equals k have roots that are different signs. You could look at this by saying, when is this graph equal to a certain value? So if you drew a straight line, so let's say you drew a straight line through here, would it intersect it at 2 different values, that 1 positive, 1 negative? And I'm actually not going to go belabor that one because we didn't look at it in that way, so let's look at it in the other way. Okay, so that's that question. As I said, we spent a bit of time on this last bit because that's what we need to look at, these nature of roots. What do roots mean? Roots mean what are the x-intercepts, and are we asking, are they different signs? Are they non-real or non-existent? Like if the graph went through there, look, there are no x-intercepts. Or do you have equal roots, in which case it would cross the axis once? Okay, now there's scribbles all over that. Great stuff.